For our first example in this lesson, we're going to take a look at the beginning of our time class case study, and we'll be using versions of the time class that we're going to introduce here in several of this lesson's examples. Now, as I've opened up the project here and just expanded in my Solution Explorer, you can see that we have two different classes that we're going to be looking at here. Time1 is in the time1.cs file, and we'll look at that first. And then time1 test is just our driver program that contains main and is going to create time1 objects and manipulate them. Now, one thing I want to point out is that because both of these classes are in the same project, they automatically know about one another. So for example, when I look at time1 test here, you can see that we never say that we need to use the class time1. We simply go ahead and start using it. And that's because of the fact that they're in the same project. So basically, within one project, all of the classes are considered to be part of the same default namespace, and in C#, classes in the same namespace know about one another, and you are not required to have using statements to be able to use those classes among the different classes within the same namespace. So let's go ahead and take a look at our time1 class, and again we're going to be looking at versions of this class throughout the lesson, so it's important for us to have a basic understanding of the class, and we'll enhance it as we proceed forward. Now, our class time1 is declared as a public class, and one of the reasons that we do that is to make the class reusable. The first step in having a class that's reusable is to make sure that you declare the class as a public class. If it's not a public class in the first place, then it can only be used within the namespace where it's originally defined, which would basically mean it can only be used within the project in this case. Within our class, we have several private instance variables. They all happen to be integers. We'll be representing the concept of the time as three integers, one for the hour, one for the minute, and one for the second. And we'll be storing the time in 24-hour clock format. So the hour will be a number from 0 to 23, and the minute and the second will each be numbers from 0 to 59. Now, we've declared these as private because we want total control over how the hour, minute, and second get manipulated. If a piece of data is declared as public, then the users of the class, the so-called client code parts of the program, would have access to that data and would potentially be able to place values into the hour, minute, and second that are not in the proper ranges. If you need to maintain data in a specific range and ensure that that data is always valid, then you have to make the data private and then make sure that your methods within the class operate on that data properly. So for example, we have a setTime method that we're defining here at lines 13 through 25. It receives three integers that are going to represent the hour, minute, and second so that we can set the time. And you can see in this large if condition that we're checking every one of those values to make sure that they're in range. So we make sure first that the hour value that's passed in, h, is greater than or equal to 0, and it's less than 24. If the hour is out of range, we're going to throw a new argument out of range exception. Now, the argument out of range exception class is defined in the system namespace, which you can see back at line 3. We have a using declaration for that namespace. And basically, this type of exception is used to indicate when a part of your code, the client code, calls, in this case, the setTime function and passes in a value that's not within the proper range for the hour, the minute, or the second. If that condition is true, that means the hour is in range, so we continue to check if the minute is in range, greater than or equal to 0 and less than 60. If that is true, we'll check to see if the second is in range. If all three are true, only then will we modify the time by setting the hour to h, the minute to m, and the second to s. Now, because of the way we constructed setTime in this example, If an invalid value is passed for either the hour, the minute, or the second, or possibly for multiple different arguments, we won't know precisely which one caused the problem. And as we enhance our time class moving forward through this lesson, we'll show you how we can construct this class better so that if somebody provides only an invalid minute, we would know specifically that the minute were invalid. So that's our set time function, which we'll use momentarily to set the time from our time 1 test class. We also provided a couple of other methods in this class, one called toUniversalString, which as you can see is going to return a string, and the string that it's going to return is the result of the static method format that's part of the string class. Now remember, in C# the string keyword is equivalent to the .NET string class with a capital S that's part of the system namespace. So in fact, if you hover over the keyword, you can see in the tooltip that it says it represents the class system.S string. So our string format is going to use this format control string to format the hour, minute, and second respectively. The hour will be placed into placeholder 0, the minute into placeholder 1, and the second into placeholder 2. And in each case, the colon D2 indicates that we want to format the integer value, D is used to represent integers, using a field of 2, so they're going to be formatted in 2 digits in each case. So if the hour is 7, it's actually going to show up as 07 by default. Similarly for the minute and second, if it's a single digit number, it will have a preceding 0 and then the digit. For 2-digit numbers, it will simply display that number in each case. So basically the format for the universal time as we're going to return it will consist of 2 digits for the hour, a colon, 2 digits for the minute, a colon, and 2 digits for the second. Now previously we've introduced the toString method of a class, and again this is a special method in C#. Every single class has a toString method. If you want to define your own, you must define it as shown here on line 35, and this override keyword is part of the inheritance and polymorphism concepts that we'll be presenting to you in the next 2 lessons. For now, we'll just ask you to mimic what you see here. And basically what this says is that toString is going to return a string. It will take no parameters, same thing for toUniversalString up above. And the format in this case is produced by the highlighted part of the code, including that parenthesis there. And basically we're going to produce a format that consists of a 1 or 2-digit number for the hour, a colon, 2 digits for the minute, a colon, 2 digits for the second, and then we'll follow that with the string AM or PM depending on what part of the day it is. So we'll use the toString method in this class to produce the 12-hour clock format string. So you can see our placeholders here. We have 4 of them in this case. The placeholder 0 is going to display the result of this conditional expression. If the hour is either equal to 0 or the hour is equal to 12, the resulting value will be 12 and we'll place that into that placeholder. Otherwise, we'll use the remainder operator to figure out the remainder after dividing the hour by 12. And in that case it's going to be a number from 1 to 11. We already took care of the 0 case explicitly. So if it's either noon or midnight, we'll be displaying a 12 here. Otherwise we'll display a 1 through 11. Then we'll display the minute and the second in the next 2 placeholders using 2 digits for each one. And then finally we'll use the last conditional expression to say if the hour is less than 12, 0 through 11, we'll display AM. If it's 12 or greater, we'll display PM, or not display, but return PM as part of the formatted string. So our time 1 class, just summarizing, consists of 3 integers for the hour, minute, and second, the ability to set the time using the setTime method, and the ability to get a string representation of the time. So now that we've introduced the time 1 class, let's go ahead and use it in a program. And here we have a main method that's just going to test the features of the class time 1. Now before I walk through the code, I'm going to run it so that we can take a look at the output as we go through the code. So here in main at line 10, we've created a time1 object which we've named time, and we're assigning it a new time1 object. The empty parentheses here are calling class time1's so-called default constructor. Now we have shown you previously how to create your own constructors in a class. If you don't define any constructors in a class, the compiler will automatically generate a so-called default constructor that takes no arguments and performs just default initialization on the objects within a given object. Now for integers, the default value is going to be 0, but as you'll see in subsequent examples, we're going to define our own constructors to allow us to initialize the time as we create it. So remember, what's really going on here at line 10 is that new is creating an object of the class that's specified to the right of new, and time1 is a variable that refers to that object. So time does not store hour, minute, and second. It refers to a chunk of memory in which hour, minute, and second are stored, and that is the new time1 object that's assigned to the variable time in this case. Now at lines 13 through 17, we wanted to display for you the initial values of the hour, minute, and second, and the only way we can do that in this example is to use our methods that return strings. So here we have our time object being told to display itself or give back a universal format string. So we call the time1 class's toUniversalString method, and it gives us back a string to display with console.writeLine. And similarly down here at line 16, we tell the same time object to give us its string representation, and interestingly we're explicitly calling toString here. However, one of the nice features of the toString method is that it can be implicitly called anywhere where we use a time object and a string is expected. So I can actually remove the .toString call here, and it will still produce a call to toString for me to get the proper string format, and I'll show you that in just a moment. So let's go ahead and take a look at the output so far, and we're talking about just these first two lines of the output, and you can see that when we created the time1 object with the default constructor, automatically it set the integers to 0, and for the universal time we simply display the value or return the value of the hour, the minute, and the second respectively in the format that you see here. And for the toString method, remember that we format the time into 12-hour clock format, so all zeros for the time represents midnight or 12 a.m. Now just temporarily I'm going to take off the .toString call here, and I'm going to rerun the program. So I can say debug start without debugging, or type Control F5, and you can see that we still get the exact same string being returned in this case and output, and that's because there is an implicit call to toString that's happening in line 16. So let me go ahead and change that back to the way it was. Now we have a limited interface, if you will, to the class time1. We have the ability to get string representations of a time1 object, and we have the ability to set the time. So we wanted to demonstrate that as well here at line 20. We're telling the object that time refers to, which I often refer to as the time object for simplicity, to set its time to 13, 27, and 6, so 1:27 and 6 seconds in the afternoon. And then we're going to once again display both the universal and standard time formats by telling that time object to give us back its universal string and to give us back its other string format, which we've defined as the 12-hour clock format. So if we stop there for a moment and go back to our output, we can see that the call to toUniversalString produced 1327:06 because of the single-digit number. And for the toString call, we got 1:27:06 p.m. in this case. Now, you'll also recall that the way we defined set time was to validate the data that was being passed into the setTime function and make sure that we only allow a valid value for the hour, the minute, and the second to be placed into the time object. Otherwise, we're going to throw an exception from this method to indicate back to the caller that there was a problem with one or more, I should say, of the arguments. So here at line 30 in this try block, we're going to try to set the time to all invalid values. None of these values are in range for the hour, the minute, or the second. So line 30 is going to cause an exception of type argument out of range exception. And you can see following the try block that we immediately specify a catch for that type of exception. And we're going to show you what the exception's message string was. There's a default string associated with that type of exception, which will follow by an extra new line character to skip a line in the output. And if we go to the output now, this is the line of output that we're talking about. Specified argument was out of the range of valid values. That's the default string that's embedded into an argument out of range exception by the .NET framework. And you can customize the strings as well when you throw an exception by specifying an argument, which is a string, to the constructor for the type of exception that's being thrown. So if a bad value is passed into the setTime constructor, as soon as we discover that bad value, it will jump to the else part and throw that exception. And in our main method, to demonstrate that, we wrapped a call to setTime in a try block and then caught that type of exception. And then finally, to prove that setTime did not modify the time when that bad data was provided, we go ahead and display the values of the time1 object. And if you look at the last two lines of the output, you see that the values are the same as they were before the call to setTime with the invalid values. And what that does is it emphasizes that we as the designers of class time1 have complete control over that data. The way I define that class, I did not allow a bad value to be placed into the hour, the minute, or the second. Instead, I threw an exception to indicate that there was a bad value, and I did not allow the object's state, if you will, to be modified when that bad value was supplied. And that's typically the case when you are using an object of a class and you give bad arguments. Normally, the object's state should not be modified when a bad value is provided. Instead, the program or the class should typically throw an exception back to its caller to indicate that there was a bad value in the first place. In subsequent examples, we're going to be enhancing this class to be a much more robust class definition.